Alright, so this is the last video for this lab, hopefully. And so we're going to take our basic single measurement system and have it take a set of data, and that will get us ready for the calibration lab that will start next week. Okay, so I've got, you can see on my screen, I've got my basic system. I'm going to save it so I can reuse this because this is the good test case. LabView has some strange menus. This is one of them. When you do save as, so let me do it slower here, file, save as. Normally, if you're used to save as, you just give it a name and it does that. It gives you three options and they're explained in these text, but it's pretty confusing. This top one is basically the usual save as. Basically, you're making a copy and you're giving the copy a new name, and so it's whether you close the original and open the copy or close the copy and open the original. So this one keeps the original open and just saves the copy off to the side, closes it, so that's sort of backwards. And this opens them both, so they're both open and you can copy and paste back and forth or something, I guess, I don't know. Anyway, this is the usual save as. And so I will just give it a name over here on this other screen. And so now I've got a fresh copy that I can mess up. So if we see what our goals are, the first goal is to take n samples, like 10 samples or 1,000 samples, using a for loop. So we've seen the while loop before. We haven't done the for loop yet. So they're very similar. So I'm looking for X structures way up here at the top. And the programming menu structures for loop, or you could just type for loop in the search, something like that. But I want the for loop, and again you drag a window. And I'm going to be careful where I drag the window because these are initialization things. These are finishing up things, so I'm going to have all the middle things inside my for loop. So my for loop, the way this is going to work, when I click run, it's going to figure out what serial port and which channel, and it's going to pass that information into the for loop, and it's going to initialize our linx device and send that into the for loop. And then the for loop's going to run n times, however many times we want, and then when the for loop is finished, it will send any errors and the handle of our linx device to the closer, and all of that will happen at the end. So here it's going to try to run a bunch of times. You can see we've got the broken arrow again. There's something wrong, and it's that for loop, we have to tell it how many times. So that connects right up here to the loop count, and I'm going to use our shortcut where I right click and create control so I can have a number of samples. So this is the number of samples that I will start with. So to make it bigger than 0 or it won't run, so I'll put 5 for now. And now it's okay. So if I run this, got my connection still made, looks good. Run it. Oh, it crashed. Sometimes you just have to try it twice. Yeah, second time's the charm. So it did run 5 voltages and then it worked. I see that when I have to start it twice sometimes. I don't know why. So that works, but we didn't do anything with the data. So I've got my n samples, so that's good. The next thing I want to do is save all those samples to a file. So that is so what happens each time through this loop, there's data, it saves things, and it can send that out of the loop. And so there are other ways to do it, but this is kind of built into this for loop. There's a way to save data. So if I put outside of this loop, I'm going to go to express output write to measurement file. So I want this write to measurement file block. I'm going to put it outside of the loop. And these blue blocks are called express blocks, and they're the ones that you have to configure. So you can configure it with the inputs as well, but this, and they will override whatever's inside the little wizard. But I will do this. So I want an Excel format. I'm going to save it to one file. If the file already exists, I want to append to the file. Append means add to the end. So it saves the old data and adds the new data. Excel format. And I'm not interested in time here, so I'm going to leave time off of this. And that's good. And the other thing we can do is we can change where it's saved. So right here it's saving, the default directory is in your documents, LabVIEW data test. I'll leave it in that same directory. And I'll call it test array just so I have something new there. Again, you could set a control and have that on the front panel if you'd rather. So now I have a place to send the signals. I'm going to connect it right up to here. And it did a few things on my behalf. And LabVIEW is good at guessing. Sometimes it guesses correctly and sometimes it doesn't. In this case it did. So let's look at what it did. It's got a single value, one from each time through the loop we get a single number, and that's going to be displayed on the voltage each time through the loop. We'll update that display, that indicator. And then it sends it here. And these things that go through the edges of loops, these blocks like this, not the resizing handles, but these guys, they're called tunnels. And these are also called shift registers. So it put these in when I made the loop. And I would normally have these be tunnels, but I think it seems to work fine, so I'll leave it alone. This is a tunnel as well, where the data is coming out. And if you right-click on a tunnel, it's just the place that the information gets passed. There's tunnel mode and indexing. So if we do last value, it'll just do all the loops and then send the last value out. Indexing makes an array. It saves them all together with the loop index. So that's the one we want because we want to save all. We've got 5 loops, so we want to save 5 values and save them. And so that's what this little shape means compared to this little shape. And we get a fat wire out here because it's an array versus a thin wire. So this has all of our values. These express blocks take dynamic data, which has time associated with it. And there's no time on this signal. So this is a converter that adds time. It adds fake time. It makes time up. So it's not good time. It doesn't have the time. So anyway, but it needs it, and so we don't, and then we throw the time away. So that's the way we make this work with the write to measurement file. So now I can run this. Hopefully it works. Should take 5 samples. If I find my spreadsheet here in the directory, here's test array, and the preview, I've got 5 measurements of 2.59 volts, and up here 2.59 volts. So it seems like it's working. I can open it in Excel, and there they are too. If you open this in Excel, you have to be a little careful. Autosave probably shouldn't be on because it makes a very simple Excel file, and when you try to append new data to it, it won't understand it if Excel has saved it. And also if it's open in Excel, then LabVIEW can't get to it. So you always have to close it here before you run again. I've moved my knob, so I'm going to run it again. Looks like maybe that worked. 3.92. So let's open up here. And we'll click on it again. Yeah, so we've got our first 5 numbers and our next 5 numbers. So it took a bunch of measurements. It changed a tiny bit this time, but we don't see any change there because the knob didn't move. So we're looking good. Okay, so the last thing we want to do, we've saved the array, is to slow things down. We want to take samples not as fast as possible, but we want to have a dt or delta t between the samples, which will give us the sample rate we want. And so I'll show you how to do that next. So there's a block we can use. It's under the timing window in the block diagram, and it's called wait, and the units are milliseconds. So I put that inside of my loop, either a while loop or a for loop. This works. It will slow it down. So basically the loop runs and it checks all the blocks and says, are you done? And this one says I'm done, this one says I'm done, and then it runs the next loop. And when these say they're done, it runs the next one. So this little block just says, I'm not done, I'm not done, I'm not done, until a certain amount of time has passed, and then it lets the loop continue. So it can't speed the loop up, but it can slow it down. And I will put a control here so we can slow it down in milliseconds. And I will put it out here. So now taking it outside of the loop means that it is sampled just at the beginning. So if I change this while it's running, it'll be ignored. So that's a little bit safe. I'm just going to call this delta t, dt. And I'm going to remind myself that it's in milliseconds, because 1 millisecond is really fast. So now I've got it configured to take 5 samples on COM11, channel 0. So make sure you set all of these up before you try to run it, because if you put 0 samples in, it won't do anything. I'm going to make 500 milliseconds. So that's a half a second between each sample. And then I'm going to hit run, and I'm going to wiggle the knob while it runs. So let's see. Wiggling the knob. You can see the voltage changing here while it ran. And then if we look in our file, we should have 5 new points that show that things changed while it was running. So that seems to be working. I will run it again. So when I run it, I turned my knob all the way down one way. So watch here, and I'll slowly change the knob in one direction. So it should go from small to big or big to small. I think small to big. So I'm going to run 0, 4, 6, and it's done. And we can go back and check. I'm just using the preview here. And here, 1, 2, 3, 4, 5. The last one matches the last one shown, so it's looking good. So if you get to this, now we can save data for a calibration. Right? We can take a bunch of samples. We can change the input on our potentiometer knob, and we can record the output. So that's the basics, and that's what our next lab will be. Doing calibration. We'll add some fanciness so that we can record the position of the knob or whatever we're calibrating, and we'll do a few other things, but this is the basics. So if you got this working, good job. If you're stuck on something, get in touch, and otherwise I'll see you in the next video.